Alright, this is for Algebra 2 solving systems of 3 equations, 3 unknowns. 7 I think most people got through in class, and possibly 8 as well, so I'm going to start with problem number 9. And so here's our system that we're presented with. They tell us x minus 2y plus 3z equals 12. There we go, it's an ugly 12. And 2x minus y minus 2z equals 5. And notice I put that little hash through my z's. I did that on purpose because I don't want to confuse those with the number 2, because that would present a problem. And then our third equation is 2x plus 2y minus z equals 4. So I would double check my equations, make sure you've written them down correctly, because there's nothing worse than solving or going through all this work only to find out you've written the problem down wrong. Alright. At this point, all three equations have all three variables in them, so you have to decide what you want to get rid of. Let's go ahead and get rid of the x's. And the reason we're going to choose the x's, or at least I would, is because notice equation 1 just has an x sitting right there. And both of these equations have a 2x. So I'm going to use this combination. I'm going to use equation 1 up here with equation 2, and I'll get rid of the x value. And then I'll use equation 1 with equation 3, and I'll get rid of the x value. And the nice thing is, if you notice, both equation 2 and 3 have a 2x in front of them. So I'm going to use equation 1, and I'm going to take it times negative 2. And that equation is going to become, in this kind of dark blue, if I can find that pen, negative 2x plus 4y minus 6z equals, and that's a 12 up there, so it's going to be negative 24. And now in green I'm going to use equation 2 with it. So this is again equation 1 and equation 2, and it's 2x minus y minus 2z equals 5, and I'll add those two together, eliminating the x's, just like I wanted. And let's put that in some red so we can see that's an important equation. We get 3y minus 8z equals negative 19. Okay. Next I'm going to do the same thing with equations 1 again, but this time with 3. Now notice I didn't have to, I'm using it in the same form I did just use it in. This is equation 1 times negative 2. And I can do that because the third equation also has a positive 2x at the beginning. So that modified equation 1 was all set up to work with equation 2 and equation 3 to eliminate x. So I add these together, I get 6y minus 7z equals negative 20. So at this point I have two new equations, those are both shown in red, and it would help if I could read what I'm writing here. I'm looking at the second one in red. I got 6y minus 7z, I'm not sure what I was writing there, minus 7z equals negative 20. So now I've got these two equations in red, and they both have the same unknowns, y's and z's. And so I'm going to combine these two equations and eliminate something else. And eliminate the y or the z. I think based on multiples of 3, it's probably the easiest one to get rid of the y with. So I'm going to take this first red equation times a negative 2, because that's going to give me negative 6, and I've already got a positive 6 in the other one. So when I multiply, I get negative 6y plus 24z equals positive 38. This other red one I'm going to line up right underneath it, and I have a positive 6y minus 7z equals negative 20, just rewriting it. And when I add those two together, and so we get 17z equals 18, and I'm not liking that answer at all because that gives me z as 18/17, and that's not right. So I've made a mistake somewhere. Let's see if we can find it here really quick. I'm going to start by looking back over here. 6y minus 7z equals negative 20, so I check my math. That is indeed negative 20. It's negative 7z, and that's 6y, so that one looks right. Let's check back over here. I'll double check my initial problem 1, that's negative 2x plus 4y minus 6z minus 24. And my green one, number 2, is 2x minus y minus 2z equals 5, and I add those up. 3y negative 8z equals negative 19. Still looking. Times negative 2. I'm checking this multiplication now. Negative 6y. There it is. Close to the end. Right here I had a 24z, and that's incorrect. It's negative 2 times negative 8. That's going to be positive 16z. So I'll do a little bit of erasing, and we'll re-add those together. And that's going to give me 9z equals 18. Therefore, z is 2. Okay, so we found our z value. Now remember, we have to find all of the variables' answers, so we got to find x, y, and z. Now, once you know z is negative 2, what you want to do is go back up to one of these equations that only have two variables in it. So here's one right here. And we'll plug in what z is. It's 6y minus 7 times z is now 2 because we just found it. And we solve that. 6y, that's negative 14 equals negative 20. 6y, adding 14 to both sides is negative 6. Looks like y is negative 1. So we have our z value, we have our y value. Now let's find x. And to find x, we go up to one of these original 3 equations up here. Doesn't matter which one you pick. I think I'll pick the middle one in green. It looks like it's relatively easy to solve. And I go 2x minus my y value, but y is negative 1. Notice how I put it in parentheses to keep track of that negative. My z value is a positive 2 equals 5. So it's this green equation with the y value and the z value plugged in. I go about solving that. I got 2x plus 1 minus 4 equals 5. 2x minus 3 equals 5. 2x equals 8. And therefore, x is 4. Let's put that in a red square too. And so my final solution, my ordered pairs, let's see if we can find some obnoxious color so you can really see what it is. Spin this thing. I don't have very many obnoxious colors apparently. But we'll try that. Our final answer is the ordered triplet x, z, and our x, y, z, 4, negative 1, and 2. Okay? So that's problem number 9. Let's go ahead and I'll do one more of these things. Let's do problem 12, because 12 looks like it could be a headache. I'm going to pause this and I'll put 12 as a separate video, so that way you can watch shorter videos if you need.